Hey guys, it's Mr. Wolfe here, and I'm going to be going over pedigrees. So really what these are is they're essentially family trees, but we have certain types of conventions that we use when making them that allow us to determine someone's family history and possibly allow us to determine someone's genotype when it comes to the probability of them passing on a trait or carrying a trait that they could pass on to their offspring. So what I want you guys to do first is to complete this page right here along with these questions on the next page where we get all the way up to number 10, and I actually want you guys to try to draw this problem here. So when you're finally done working with these pages, you could click on and keep on watching. All right, so here's the pedigree that I came up with for number 10. And it says that there's a girl with a recessive genetic disease. So, ooh, by the way, I should probably make a key anytime I have this. So I'm going to have big A, little a, and it looks like the disease, it's not being specific on which one, is going to be recessive, and so like a normal condition we would say is going to be dominant. So here's our key right here. And it says that she has this disease. So whenever you have, like, you're affected by something, and by the way, it doesn't have to be a disease. We could just be talking about eye color, right? Like you're affected with brown or blue eyes. Whatever we're talking about, you shade that person in if they have that phenotype of interest. In this case, it's the phenotype of interest is the disease. So the girl, and oh, by the way, we make it a circle because she's a girl. We shade her in. She has two sisters, so I made two other circles right here, and she also has a brother, so a square that is affected by the disease. And then her parents are shown right here, and we have the mother that is also affected by the disease, so she's shaded in. So a couple extra things that I'm going to add to this pedigree that isn't directly asked for number 10, but it's important to go over, so this is, you could kind of think of this as like your notes to go back to, is labeling the generations. So I'm going to start with the parent generation, and this is going to be generation 1, which would make the children generation 2. And if I were to keep on going on, this would be like generation 3 down here, and so on and so forth. Now, we could also label it in a different way. So sometimes biologists will just say, especially if you are like a breeder or you're doing something with plants, you're going to say, okay, this first generation is going to be my parent generation, and then my first offspring, I'm going to label as F1. And then if this were to continue, right, if these brothers and sisters were going to get married and have kids, it would go on to F2, and so on and so forth. Right. So we have a family tree right here, but how is this useful when it comes to inheritance? Well, let's say that this sister right here ends up getting married to a guy, and they want to have kids, and let's say the guy is also affected by the disease, and this couple is maybe concerned or just curious, what's the probability that these two individuals are going to create an offspring that has the disease or an offspring that doesn't have the disease? And normally I just kind of give you guys those genotypes, right? Like big A, little a, and so on and so forth. But in this case, and what we normally have is just the phenotypes, what we observe. However, once we have this chart, it makes it much more easier to figure out our individual's genotypes. So let's go over an example. So in this case, if you have the disease, it's the recessive allele. So if you have it, if it's shaded in, the only genotype you could have would be little a, little a. So anytime I see a person with the shaded box with the disease, I'm going to make their genotype little a, little a. This also means that if you don't have the disease, you have the dominant allele, and all you need is just one. So for everyone, I'm just going to draw a big A, a dash, a big A, dash. Right? Because I'm not sure, at least yet, what this allele might be. Okay, so what I could do though is I could kind of look at the family history and say, can I figure out what this missing piece is? So if I look above, I could see that, all right, we got this big A. It looks like we could only have this sister could have only gotten this dominant allele from the father in this case, because the mom has two recessive alleles. So I know that we got the A from the father, which means that this other allele couldn't have come from the father, it came from the mother. And the only allele that the mother could have passed down was the little a. So we know for a fact that this sister's genotype is big A, little a in this case. Right? So we could now solve a Punnett square between our new husband right here and the sister. So I went ahead and did the cross, and what I found was that for the phenotype, the probability of having a normal phenotype versus having the disease is 1-to-1, which is essentially saying that like 1/2 or 50% chance of having a normal phenotype, a 1/2 or 50% chance of having the disease. We're just expressing it like a ratio right here. All right, so I'm going to try these other ones as well. And so for this sister, well, she got the big A again from the father, which means that she had to get her next allele from the mom, had to be a little a in this case. All right, now let's look at the father right here. All right, so we have a big A right here, and the problem is I just don't have enough information at this point in terms of what allele he has right here. Now, if I was able to get a family history of, let's say, his parents and everything, maybe I could figure out his genotype. And there are going to be times where you just simply don't know from the pedigree, but as we saw here, there are times where we're going to be able to figure out for certain what someone's genotype is. So with this in mind, I want you guys to go to this page of your packet with these practice problems, and you don't have to do all of them, but I do want you to try out the first one right here. So the same type of thinking that we were doing before, where let's say we have this autosomal recessive disorder, well, we automatically know that the shaded boxes or the shaded individuals are going to be homozygous recessive. So we're just going to draw little a for each one, and then big A, a dash for every other one. And I'll let you guys complete this, but use the same type of thinking that we did here for figuring out our genotypes as you do here. So you're going to figure out which ones absolutely we know are carriers, and then which ones could be carriers for this autosomal recessive disease. Right. Another practice that I want you guys to try, and you don't have to do the whole page, but just do this first one right here. Actually, you guys are going to do the second. I'm going to go over the first as an example. So here we have an example where is it possible for this pedigree to be autosomal dominant, and then select yes or no. So what I'm going to do here is it's kind of going to be like a guess and check. I'm going to say, okay, I'm going to assume that this trait is autosomal dominant, which means that this person would have to have a big A to have this phenotype right here. I don't know what allele he has, at least for right now, what this person has. And then this is a guy because of the square. And then I know that this woman right here, if she does not express this dominant phenotype, well, she's expressing the recessive phenotype and has both little a. Same for the parents as well. So I'm going to fill this out, and then I'm going to say, okay, looking at this, is it possible for this guy to have gotten the dominant trait? And when I look at this, there's no way, right? Like, there's no dominant A allele for the parents to have passed down, so this trait could not have been autosomal recessive. Right? And again, the reason why is the parents do not have a dominant allele to pass down. Right. So the same type of like just trying it out, see if it works, or seeing if it doesn't, try that with problem number 2, and that's it. Thanks for watching, guys.